In this presentation, we're going to talk about the different network protocols and the standards. During this presentation, we're going to define what is a network protocol, the standard bodies and standardization, talk about the OSI and the TCP/IP models, the core internet protocols such as IP, TCP, and UDP. Then we're going to also talk about the ICMP, which is involved in the network diagnostics, the application layer protocols such as HTTP, DNS, FTP, and SMTP. We're going to also talk about the network configuration protocols such as DHCP and NAT, PPPoE, which stands for point-to-point protocol over Ethernet, and universal plug and play. And finally, we will be introducing the legacy protocol, which is the IPX, and we have a quick summary and key takeaways. First of all, what is a network protocol? A network protocol is a set of rules governing data exchange between networking devices, but in most cases computers. Protocols define the format, timing, sequencing, and error control of messages, and without those protocols, computing devices wouldn't be able to communicate together over a network. And a network standards for those protocols are defined by RFCs, which are requests for comments, IEEE specifications, which ensures that devices from different vendors can communicate reliably. The standard bodies and standardization. We have the IETF, which defines the internet protocols such as TCP, UDP, HTTP, DNS, and SMTP. We also have IEEE, which defines the local area network and wide area network standards, which the current ones are the IEEE 802.3 for the Ethernet and IEEE 802.11 for Wi-Fi. We also have the ISO, which defines the Open System Interconnection (OSI) model for network architecture. And finally, we have the W3C, which defines the web standards such as HTML, CSS, and other web protocols. Together, those standards ensure that interoperability is possible and is reliable and security across the heterogeneous networks. For the OSI reference model, we have 7 layers, and it is a top-down architecture where in the 7th layer we have the application, which include the HTTP, DNS, SMTP, and FTP. The 6th layer, which is the presentation layer, which includes transport layer security and JPEG compression. The 5th layer, which includes the session layer for session management. The 4th layer for transport, which include TCP and UDP. The 3rd layer for network, which include IP and ICMP. The 2nd layer for data link, Ethernet, and Wi-Fi. The 1st layer, which include physical cables and signals from a computer. The 7th layer are key concepts for this framework, and each layer provides service to layer above depending on the layer. And they are used primarily as teaching and reference models, such as TCP and IP is the practical standard nowadays. For the TCP/IP model, it is the practical standard, and usually we use 4 type layers to define them, but we can also map them to the OSI layer. The first one, which is the application layer, which maps to the three down layer from the OSI model, which is the 5, 6, and 7, which includes HTTP, DNS, SMTP, FTP, and SSH. And we also have the transport layer by itself, which map directly to the transport layer in the OSI model, which include TCP and UDP. We have the internet layer, which is equivalent to the 3rd layer in the OSI, and this includes the IP and ICMP. We have finally the network link, which includes the 1 and 2 layer from the OSI, includes Ethernet, Wi-Fi, and ARP. Those layers in this model, the TCP/IP model, includes the functional protocol suite for the internet, which is defined by the DRPA in 1970s. Includes 4 layers that we just explained that maps onto the OSI layers, and this model underpins all modern internet communication nowadays. For the Internet Protocol, it is part of the network layer but maps to the layer 3 of the OSI, and it is also part of the TCP/IP model, and it adheres to the RFC 791 for the IPv4 and RFC 8200 for IPv6, and its responsibility is for logical addressing and routing of packets across the networks. It is a connectionless protocol and provides best effort packet delivery but no reliability guarantees. And all higher layer protocols depends on IP4 end-to-end packet delivery. It is important to also note the difference between IPv4 and IPv6. And IPv6 was developed to resolve the issue of not enough addresses, IP addresses from IPv4. So the originally IPv4 had 32 bits for address space, and it was extended to 128 bits in IPv6 to have more addresses. For example, for IPv4 we had this 192.161.1.1 as address, but it was converted to this much larger extension for IPv6. And IPv4 provides around 4.3 billion addresses, but IPv6 provides a much larger number than that. And IPs are basically what you use to identify your computer on a network. The Transmission Control Protocol, or TCP, is a transport layer protocol. It uses the RFC 793, and its responsibility is to provide a connection-oriented, reliable, and ordered delivery of data. The key features of the TCP are it uses a three-way handshake mechanism, where first you have the client and the server. The client sends a SYN request to the server, when then the server, upon receiving that request, send back a SYN ACK request to the client, and finally the client sends a last signal to the server as ACK signal to set up the connection. And it also has a sequence numbers and acknowledgement that's defined the two-way handshake to ensure in order reliable delivery. It also has a flow control, otherwise a sliding window that prevents receiver overflow. And finally, it uses the congestion control mechanism to regulate transmission rates. The use case for the TCP are mainly HTTP, SMTP, IMAP for emails, SSH, FTP, and other applications that requires guaranteed delivery. For the User Datagram Protocol, or UDP, it is also a transport layer protocol as the TCP. It uses the RFC 768. It is connectionless, meaning that it needs no connection setup, but it is unreliable because there's no delivery guarantees. The main characteristic of this protocol is that it provides a low latency delivery, but the applications need to handle the errors by themselves. The key use cases for this protocol are that you can use it as a DNS queries for voice over IPs, video streaming, and online gaming, which needs speed over reliability. The ICMP, or Internet Control Message Protocol, is a network layer protocol that uses the RFC 792 for IPv4 and RFC 4443 for IPv6, and its functionality is to produce network error reporting and diagnostics, but it doesn't carry any application data and only support network troubleshooting. You can use applications such as ping or traceroute to test the network reachability, whether you want to find out if the destination that you send the packets is reachable or not. If it is not, it will send a report that characterizes the failures, and also test whether the packet time to leave has exceeded, and it's an essential tool for network diagnostic and operation. You can additionally use applications such as Wireshark to test the network diagnostics, for example, to find out whether a packet that you sent over a network has reached its destination or a port properly. The HTTP, or Hypertext Transfer Protocol, is an application layer protocol which maps to the OSI layer 7. It uses the port 80 for HTTP connection and 443 for HTTPS. And its responsibility is to transmit hypermedia such as HTML, JSON, or other media files using client-server model. Throughout the HTTP history, there have been different versions. The first one was HTTP 1.0, which uses the RFC 1945. It was released in 1996 and it has header status codes but provides only one TCP connection per request. The second one was the HTTP 1.1, which uses the RFC 2616. It was released in 1999 but provided additionally persistent connections and pipelining. The third one is the release of HTTPS, which is the just HTTP plus TLS, transfer layer security, and it uses the RFC 2818. It was released in 2000 and provides encryption, integrity, and authentication. The next version is HTTP2, which was released in 2015, uses the RFC 7540. It provides binary framing, multiplexing, header compression, which is called HPAC. The last one and the current one is the standard version is HTTP3 that uses RFC 9114. It was released in 2022. It runs over quick UDP and internet connections and eliminates head of line blocking, which provides lower latency. In HTTP, there are different methods that we need to consider. So those methods are usually classified based on their characteristic, whether they are safe and idempotent. Safe means that in terms of modification of the data on the server, are they safe or not? And idempotent means how many times you execute this operation, you will still get the same outcome or not. For example, for the get method, which is a common method that we use to retrieve data from the server, it is safe because no matter how many times you make a request from the server, if the data has not been modified, you will still get the same result. So that means it is idempotent. And it will not modify the data on the server, meaning that it's safe. The post method updates the data on the server because it adds a new data instance to an existing file or resource on the server. And it's not idempotent because different execution of this method will result in different outcome. And the put method is used to update or replace an existing file in the resource in server. And the delete, has the name suggests, delete data from the server. The patch method is somewhat similar to the put method, but it updates a resource partially or modified. Additionally, we have the head method that is used to retrieve the resource header, the connect method that is used to open two-way socket connection to a server. The options is used to describe the communication options for a specified resource. And finally, the trace method, which is designed for diagnostic purposes during development. Another important concept when using HTTP for communication are the status codes. The status codes basically translate the meaning of the response of from a request. For example, when you make a GET request to a server, it might respond with the status code 200 and the message OK, means that the request was successful and the server accepted the request. And the server response might also include other type of information such as the response headers that might include information such as the content length. As we can see here is 35 and whether the connection is alive or not, which is closed here, and also the type of information, which is text or HTML, and that describes the body of information that is used to describe the response of the server. Other types of status codes might include, for example, in the range of 300 to 399, which translates to redirection. For example, 301 means that a resource that you're trying to access has been moved permanently to another address. Others such as 400, for example, 400 is a bad request, and you can also have other ones such as 404 for not found, or other ones such as 403 for authentication failures. The last one, which might be in the range of 500, which translates to server error, maybe, for example, the server you're trying to access is down and is unavailable to respond to your request at the time. One important thing to mention for HTTP in terms of computer networks is the addition of HTTPS, which stands for HTTP plus TLS, where TLS is the transport layer security. This addition provides a confidentiality where the data is encrypted, integrity where it prevents tampering via method authentication, and the server identity is verified by a certificate which is called S.509. The key difference between HTTP and HTTPS is that HTTP uses port 80 but HTTPS uses port 443. And additionally, a TLS handshake negotiates ciphers and exchange the keys before the data transfer. And now we're going to talk about the DNS, which is the domain name system. It has for main responsibility to translate domain names to IP addresses. It is part of the application layer. It uses the RFC 1034 and 1035. On computers, it uses the port 53 and UDP for queries. The DNS has hierarchical and distributed resolution, and the process involves first the client queries the recursive solver, which can be the ISP or other public instances, and then secondly we have the resolver queries that queries the root, and then in turns queries the TLD, which is the top level domain, and this TLD is responsible for domain names that have the same extensions, and in turns the TLD queries the authoritative server, which will in turns will return the server IP and resolver caches, which respects TTL. TTL is the time to live for a packet that is sent from a client to a server. The different record types that are saved on the for the DNS system are A for IPv4 and AAA for IPv6, and CNAME for aliases, MX for mails, NS for name server, and TXT for verification. FTP stands for File Transfer Protocol. It is an application layer protocol. It uses the RFC 959. On computers, it uses port 21 for control and port 20 for data. The main responsibility of FTP is to transfer files between client and server. The key characteristics are that first, it uses two separate connections for control for commands and data for file transfer. FTP supports user authentication and historically was used without encryption, and the new replacement for FTP is SFTP, which stands for SSH File Transfer Protocol, and this new protocol uses port 22 on computers. The SMTP stands for Simple Mail Transfer Protocol. It is an application layer protocol, uses the RFC 5321. For inter-server relay, it uses the port 25, and for client submission with TLS, it uses 587. The main responsibility of SMTP is that it is used to send email from client to server and relay between mail servers. Characteristics of SMTP are that first, it uses the command response model, means that client sends mail, RCP, and data commands. And also modern deployment uses .TLS for encryption. The port 587 is required for client authentication and TLS. SMTP is an essential protocol for email infrastructure and must use encryption in practice. The DHCP or Dynamic Host Configuration Protocol is an application network access protocol when using the TCP/IP model. It uses the RFC 2131. On computers, it uses the port 67 for servers and 68 for clients. The main responsibility of the DHCP is to automatically assign IP addresses and networking configuration. The process involves 4 steps. The first step, the client broadcasts a discover signal requesting for an IP address. Then the server, upon receiving this request, will send an offer signal telling the client that he has available IP addresses. Then the client will send the request to accept the offer of the server, and finally the server will send the ACK signal to confirm the assignment of the IP address to the client. The DHCP promotes the leases of IP addresses based on TTL, time to live, and it enables dynamic reallocation. DHCP is essential for networks with mobile or transient hosts. For NAT, which stands for Network Address Translation, it is part of the network layer and enables private networks to communicate externally where the key operation is to rewrite IP headers. The key operations using NAT are outbound first, where the private source IP addresses are translated to public IP, and the response also are translated back. For inbound operations, public destination IP are translated to map internal device IPs. For port-based operation in a network, multiple internet devices can share one public IP using different ports. The benefit of using NAT is that it provides efficient IP utilization and address non-routable private addresses. But there are some limitations, such as it complicates end-to-end communication and may hinder peer-to-peer applications. PPPoE, or point-to-point protocol over Ethernet, is a data link layer protocol, and it uses the RFC 2516 and has for main responsibility to encapsulate PPP frames over Ethernet. It enables per-user authentication. It is common in DSL cable broadband, where the client discovers PPPoE server and establishes PPP session. The PPPoE maintains PPP features, authentication, compression, and optional encryption. It simplifies its ISP management of per-user credentials, and finally, it is less common with modern broadband but still used in some regional deployments. The UPnP, or Universal Plug and Play, is part of the application layer. It regroups different kinds of protocols such as SSDP for discovery, GENA for authentication, SOAP for control over HTTP. The main responsibility of UPnP is to auto-discover devices and services, and also enable automatic configuration. The use cases for UPnP are that: first, home network setups, where you can use it with printers, media servers, games consoles to discover each other. Also for port mapping, where enables external accesses to internal devices, and automatic service advertisement and control. But in terms of security, improperly configuring UPnP can expose devices and requires careful firewall rules. The last protocol we're going to introduce in this presentation is the IPX, which is nowadays an obsolete protocol. It stands for Inter-Network Packet Exchange. It is part of the network layer and was developed by Novo for network networks. The responsibility of this protocol was for network layer routing and logical addressing. It is important to know about this protocol because it was widely used in corporate local area networks during the 80s and 90s, but it lacked the inter-network scalability of IP, which quickly replaced it. Network protocols and standards are important to understand how computers communicate with each other. Protocols defines the rules for network communication, whereas standards ensure interoperability. The TCP/IP model is the practical standard for internet communication, whereas the OSI models is only used for teaching purposes. The network layer, which is the layer 3 in the OSI model, includes IP for addressing and routing, and the ICMP is used for diagnostics. The transport layer includes the TCP, which is used for reliability, and UDP for speed. The application layer involves HTTP, which for the web, DNS for name resolution, where the domain names are converted to IP addresses, and FTP is used for file transfer, and SMTP for emails. The configuration infrastructures involves the DHCP for automatic IP assignment, NAT for multi-device single public IP sharing, PPPoE for authenticated broadband access, UPnP Universal Plug and Play for automatic service discovery and port mapping. One legacy protocol that is still being talked but not used is the IPX, which is important in terms of historical networking, and it was replaced by IP nowadays. The main references for the documentation of this presentation are the two computer network books, as you can see here, and the Internet Engineering Task Force request for comments associated with the different protocols and services.